Hello, good morning, good afternoon, good evening, wherever you are.
Yep, welcome everyone. Um, this is kind of a special workshop that we're doing. This is one where we're partnering with that dot. So we have Michael on as a guest who we'll introduce momentarily. But Michael, you can say hello to the folks at home.
Hello, how you doing? Good morning.
All right. So yeah. So for this one, we're actually going to talk about that dot's streaming graph product known as Quine, and we're going to go ahead with a real-time exercise on it. But first, let's go through and again, just to remind everyone, Rags and I and Michael today are the face of the workshop, but real folks who that go into the complete building and presentation of all of this. So again, just a shout out to everyone who's behind us on this. So yay, there you all are. All right. Otherwise, for those of you who don't know me, I'm Aaron Pletz, developer advocate at DataStax. I'm also the host of the Apache Cassandra Corner podcast. So if you have an interesting Cassandra use case, I'd love to talk to you. Feel free to reach out. Otherwise, I was a software engineering lead over at Granger and Target. So I've run some large scale Cassandra clusters. And I've authored a couple of books on distributed databases, mostly focusing on Cassandra. All right, Michael.
Sure, my name is Mike Elliott. I've been running developer relations programs for the last 15 years. My background is in data-driven analytics as well as solutions architecture and systems engineering. I spent 16 years developing large voice over IP networks in the telecom industry before I left and went and focused on building applications using mostly Macs. So background architecture for online systems using like Laravel or October CMS, PHP based applications. They're generally focused on helping developers understand how to develop with products that are either new or emerging. And my role right now at Quine is the developer relations person. So I do advocation, I do a lot of documentation, I do trainings, as well as I speak whenever there's opportunities like this. So
Of
thank you very
course, and
much,
and
Aaron and
Michael,
Rax.
seriously, I love your South Park avatar there. That's pretty seriously cool. All right, Rags.
All
Thank you.
right, that's me. My name is Raghavan Srinivas. And just to confirm, we have three voices, no echoes, everything good. If you want to put a thumbs up in the chat, that'll be great. But my undergrad was in mechanical engineering. I like to see things move, and that's why I like these workshops, hands-on labs, where you learn by doing. And today you're gonna write some cipher queries, and you'll again learn by doing. I myself learn by doing on most of these workshops. But this is all not work. We're gonna have a little bit of play. We're gonna do some Menti and stuff like that. So we're gonna get to
That's
that in a
right.
moment. What I'm focused on the most, and this is kind of my mission in life, is to make inner loop a lot easier. And what I mean by inner loop is kind of the lightweight CI/CD, where you kind of develop, compile, profile, debug, and all that, and then finally push it to the outer loop. If the inner loop is faster, it leads to a lot of developer productivity, and that's kind of what my mission in life is.
All right. So, hey, we actually are going to offer a workshop badge for this session. So if you go ahead and work your way through the session and do the homework at the end, you can actually get the Quine and Cassandra badge, which would be pretty cool that you can show on LinkedIn. I know folks love to do that. So that is available for this one. Yeah, we've done our introduction. All right. So of course, as we usually do, we live stream over on here on YouTube, and also over on Twitch as a backup. We have our Discord server, which you can jump on if you have any specific questions that we may need to dive down into. And of course, we have Menti that we're probably going to start here in a little bit. All right. And of course, as for the workshop itself, we're building out on ASTRA DB today, running everything out in our virtual development environment out on GitPod, and of course that'll pull in a GitHub repo, and in addition to that, we're also going to be using Quine today to pull in or to use as like a real-time graph that kind of ingests data as it comes in and kind of builds out your graph like live for you. So it's going to be pretty cool to see. So yeah. All right. So Rags, I don't know if we have a slide that cues us to go to Menti, but I think we should go to Menti.
Sounds good. All right, we are ready to go to Menti. Just give me a second while I make sure everything is good here. I'm going to get rid of our heads because, we want to focus on Menti here, right? All right.
Yeah. I can certainly talk us through this. Well, we have 17 people in Menti, so I think that's all right. We can spin ahead for now. All right. Yep. So I hear me. So yeah, yeah. I think we can go ahead. Right. Well, that's good. All right. So, where are you from? Go ahead and kind of tag the spot where you're broadcasting in from on the map, and then submit that. There we go. Oh wow, is that someone from Quebec? That's pretty cool. If that map is showing up correctly there. Some from Europe, some from India. Oh, hey. Oh, Adriano. Outstanding, outstanding. All right. So, which of these closely match your role? Just kind of pick that out there. There we go. All right. Oh, we have a couple data engineers. Good share of developers, engineers, DBAs, and DevOps specialists. That's a plus. 2 tech executives. Hey, all right. Oh, and a data scientist. There we go. Security specialist. Wow, we've got and a student. We've got a nice range of folks in this one for sure. For sure. All right. Outstanding. Rags, why don't you jump to the next one? Yeah, there we go. So is this your first DataStax Devs workshop? Well, I'm seeing a bunch of no's, so that's good. And you know what? I'm also going to say no. Oh, hey, we've got a couple of new people. All right, that's good. Oh, several. Excellent. It's good to see some new folks out here. All right, I think that's everyone. Okay, so the big question for today, how familiar are you with the Cypher query language? So is this your first time with it? Done some tutorials? You know, have you done a project with it? Do you feel competent? Or have you used another graph query language like Gremlin, for instance? Hey, several first-timers on site. All right, all right. Yeah, some people have used other, like graph query languages. I'd be curious to know what those are. If you could put those in the chat, that would be good to hear, or good to read, I guess. Lots of first-time folks with Cypher. All right, all right. Okay, what are you most excited about changing in your data pipeline? And of course, you know, there's a lot of these. I'm not going to read through them, but the last one, if you're new to data pipelines, here to learn, feel free to tick that one. All right, lots of people looking for unique patterns, going after further insights. Yep, and some new folks. This is a good range of attendees in terms of both like, you know, role and kind of what they're looking for and what their experience is. actually have there? Easy. All right. Well, I think this means that we can flip back to the workshop. Oh, there we go. That looks good. That looks good. All right, back to Quine and Cassandra. So of course, one of the main points of our agenda for today is to kind of talk about what Quine is, and even what a streaming graph is for those of you who have not used one before. So Michael, I'll turn it over to you.
Sure, thank you. So Quine is designed from the ground up to be a real-time streaming graph. So what that means is that it will listen for events in an event stream. It'll shape those events into a graph shape using Cypher, and then it'll create relationships that can then be queried or gain insights from in real time. And we're tuned to do that in a way that allows for really quick ingestion, as well as the detection of and reporting on events as they occur. So we eliminate the need for batch processing. We bring together multiple streams into one single graph, and then we are able to move on categorical data rather than having to do the traditional data transformations that you have to do to categorical data to be able to run insights on them, as well as we really deal well with really high cardinality data sets. So things that have a lot of different variants inside of the same cell, say inside of a spreadsheet. So that we do, and we've tuned everything to be done at real time. And then on top of the graph, or inside of the graph, we also have a query engine called standing queries that allow us to constantly match patterns in graph style, so relationship-based matches that will report as soon as a match happens. So the order of data isn't as important. The data can come in any order because we're looking for a pattern. We're not looking for a temporal stream of events, even though they may come in a specific sequence, or we may need them in a specific sequence. We wait until all of the components of an event occurs, and then we match on that. And we'll talk about how, as we pull apart the recipe that we're going to go through to look for password spraying. So password spraying we're going to talk about today, as well as we're going to talk about streams and how graphs shape streams into knowledge graphs.
All right.
So architecturally, if you're thinking about where to put Quine fits into your data pipeline in between a source and a sink. So what we do is we will connect to, say, like a Kafka topic, and we will read that topic, and we'll take all of the information inside of that topic, and we can take multiple topics. And that's a really high volume of typically, low value or interesting data, but not really insightful data. So we'll bring all of that information together in a graph shape, and then we will run insights that take that high volume of data and turn it into a high value stream of insights. And those can be alerts, those can be interesting or novel activities that we see inside of the data, or they could just be a specific stream of data that's coming from the main trunk of the data. So we can carve out, say, I want to watch Sally's activities for one day, and we can put a filter in that says anything that's done by Sally across our entire data surface, we want to tap out and move to its own stream or something like that. And that's really where the value of having graph in a data pipeline really comes to fruition, because looking for something called Sally, especially if you have a specific name like their first and last name, rather than a specific ID, which may be different in different parts of your systems, makes it difficult for non-graph shaped taps to be able to pull out an aggregate of information.
I think this slide is a really good visual of you know, like kind of what goes on and kind of what needs to happen, because so many places out there have just all kinds of disparate data, and they're not quite sure how to like match up relationships between them, or really how to like mine in or use it. And I think this is cool in that it just, you know, it kind of shows how Quine like streamlines that and is able to make that data worthwhile, you know, to help it drive value. So yeah, for sure. All right. So let's talk a little bit about use cases. You know, so let's say you pull down Quine. Well, what would you use it for? And here we go.
Right. So, like I said, Quine is really good whenever you're looking for categorical types of data. It's also really good whenever your insights or the data that produces an insight has a very small shelf life, say within the span of a transaction, so seconds to minutes. The information that is going to be streaming in, if you're going to take an action on it, that's where Quine's going to be able to very expediently give you an insight on a bunch of data. And we've seen several use cases where this is really important. Log analysis, where we're doing aggregates of logs when we're looking for a specific event, or if we're looking for a specific failure event that needs a very rapid response. Streaming ETL, where you're taking and reshaping a pipeline into a different form, or you're building new insights, or you're making judgments on different events that are coming in, and those judgments have a framework or a time frame that they're valid for, and it's not something that you can do, say, in batch overnight or something like that, or even micro batching like once every 15 minutes or an hour. That information may be too old at that point in time. Real time, very distributed applications like video distribution, or whenever you're having a streaming event and you're streaming something across the world to a bunch of viewers, being able to observe how those streams are behaving, being able to route around, being able to fix or understand why some streams may be caching and some streams may not be caching, while you're trying to put out a terms of service based experience to your customers, is something that has a very, very short shelf life for those observations. It's not something that can be done, say, overnight, or even after an event has completed. And anything that is dealing with fraud is always interesting to have very rapid insights. Many fraud analyses take a very, very long time, like the span of months to sometimes even years, where if you have the right pattern matching at the right point in time, you can cut an event that maybe was detected and then resolved 6 months later. You can cut that to where you detect an event and act on it in the span of the transaction. So while that event is occurring, or very shortly after that event is occurring, before more damage or more risk to whatever the enterprise or the customer is lost.
All right. Well, let's move on here. So hey, let's talk about password spraying, because that's kind of the focus for today.
Sure. So password spraying is a really unique type of fraud. It's becoming more and more prevalent, where we're seeing large lists of usernames being spread around inside of the internet. And whenever a group that is interested in a specific target gets a list of usernames, they basically try almost like a dictionary or a well-known passwords attempt. There's a list of the top 10,000 passwords that is freely available on the internet. They will take that list of known usernames. Usually they'll farm them out of emails, or they'll farm them out of different marketing types of campaigns. They'll then just basically try walking at a very low persistent rate. So nothing that would cause the traditional, oh, you haven't signed in, or you've forgotten your password type of lockdowns, where a human trying to gain access to an event might try their password 2 or 3 times in the span of 5 minutes, And the system will say, oh, obviously you've forgotten your password, so I'm going to lock this. I'm going to make it, I'm going to send you a new password update, those types of things. Password spraying is more of a low occurrence, persistent type of a threat, where they may try walking the list and send a password to everybody in the list, once a week, once a day, but never where it would be, compromising or tripping the traditional types of password problems. And their goal is to gain access. And then once they've gained access to the network and they can get 3 or 4 different accounts, they can start to triangulate and go after very high value assets inside of the network. And what our goal is today is to be able to detect that low kind of persistence of attempts where there's a series of failures and then a series of successes. And we'll show you how that's done inside of Quine using Graph and Cipher to detect these patterns.
Right. I just got to know whose password is Cubs win 2016. I mean, come on. No.
Well, it has a dollar sign at the end,
That's
so
right.
they must have won a bet there too.
No, I'm sorry, lifelong Milwaukee Brewers fan here, so I had to chime in on that one. So. All right, so hey, we've introduced Quine and talked about our use cases and a little more detail on password spraying. Let's talk about some of the architecture that goes into Quine and some of the components we're going to be using today.
Right. So like I said, Quine is designed to be in a pipeline. So what we're going to use is a file of JSON objects, and we're going to stream that file into Quine. And there's a component inside of Quine called an ingest stream, which is going to connect that file stream and build a graph out of it. So the graph is our primary structure inside of our architecture. That graph is going to be backed with a persistence layer, because not everything can fit into memory all the time. We'd love for it to, but not everything fits into memory all the time. So the graph is going to have a persistence layer that is calling out via the API to Cassandra, which in this case is going to be ASTRA DB. So that is where all of the nodes, and we have several states for nodes, so nodes can be awake and active. All of the nodes that are interesting or that have patterns associated with them are going to have an actor-based model behind them. So they're state aware, they understand what's going on, and they understand the question that we've asked them to look for. So any nodes that are not part of answering an active question are free to move to what we call a sleeping state or a persisted state, and they're going to live still indexed into the graph, but they're going to be outside of the memory shard. They're going to be inside of a persistence layer. And then we have two special structure, or we have a special structure called a standing query, which does two major things. It can reshape or take actions on top of the graph. And we're going to show you how a standing query can change or make relationships inside of the graph, or they can look for patterns and they can emit new events out of the graph. And what we're going to do is search for, in our case, the pattern of a password spraying attack. And we're going to emit an alert that says we found a password spraying attack. And that alert can go downstream to another link, and we can become a source inside of the data pipeline. It can go out as a webhook and show up on somebody's operational dashboard, or it in our case is going to show up on time in the console. And in real time, we're going to act on that event, and we're going to go into the graph and see what's going on. So that in the highest level is the functional architecture of how Quine works and what we're going to do inside of the workshop today.
Excellent. So of course, Quine has some different persistence options available, right?
Yes. So we have two local persistence operations, which is either RocksDB or MapDB. RocksDB doesn't always play well with all systems. There was a little bit of period of time where they were lagging behind the new M1 architectures for the Apple architectures. So we also support MapDB. Both of those are really great for prototyping or doing very small data sets, something that you're not going to be looking for an event that happens over the span of a week or 2 weeks or something like that. Our production data sets, our persistence layer is predominantly ASTRA. We have some people that have tried to do it with RocksDB, but they rapidly grow out of RocksDB and end up using Apache, Cassandra, and in some cases ASTRA. ASTRA's our preferred.
Excellent. So of course, a little bit about Apache Cassandra. Most folks on here, probably know at least a little bit about it, but essentially with Cassandra, what you're getting is that distributed data architecture spread out over many different compute instances. You know, um, Cassandra works with like a gossip protocol because all of the nodes are they're all peers, so there's no like primary node or secondary node. So they don't have like individual roles or anything. But they all kind of work together in sort of like a token ring architecture. At least for now, until we get to Cassandra 5. We'll talk about that some other day though. But so typically, with Cassandra, you have a database architecture that can scale linearly. So once you figure out what your throughput is, and then maybe what your desired throughput is, it really gives you insights into just how big you need to build that cluster, and just how much you can get from it. Now, Astra, of course, is Cassandra as a service, essentially run by DataStax. The great thing about it is that there's no operational overhead. So you get that no-touch scalability. And it's not bound to a single cloud vendor either. You can run it on AWS or GCP or Azure. And of course, you get that Cassandra like best-in-class geographic awareness that it comes with as well. So if you have applications or other systems that are running like on the West Coast, and maybe you have that same data set needs to also be on the East Coast, but you want those data sets to be the same. You want them to be in sync. Again, that's something that Cassandra and Astra do very, very well. Do you see that one, Michael?
I don't. Unfortunately, I only have one window.
That's fine.
Today.
Can we execute multiple graphs at the same time in Quine?
Quine is going to have one graph structure inside of it at any point in time. You can have subgraphs inside of that structure, but it is always going to have one graph inside of an instance of Quine.
Right. That's a good question.
Yeah. Okay. So one of the important things inside of Quine, and this actually kind of goes to the ability to have subgraphs or disconnected graphs inside of Quine, is the concept of indexing. And like I said, Quine is designed for streaming data. It wants to act on data while it's still in motion, before it becomes restful. And to be able to do that, we had to rethink the way that we approach indexing inside of the graph itself. And traditional indexing, where you will have like a continuous index, or basically every node gets like a sequential index or something like that, means you have to kind of go look for the node and then get the index for the node. You can't just know where the node is going to go to be indexed inside of a graph. With Quine, we introduced a function called ID from, which basically takes any number of inputs, and generally it's going to be something that is a namespace type of value, and then something unique from the data, to deterministically calculate what the node ID is going to be. And what that allows us to do is to, as we ingest data in that ingest stream, we can place it into the graph indexed in the way that the rest of the graph is going to be. So we never have to know where the sequence counter is. We never have to look up where the relationships are. We can basically point a node into the graph by calculating what its index is going to be. And that becomes really powerful for whenever we're also creating relationships between nodes that may or may not exist at the point in time where we need to create the relationship. We can calculate what a node ID is going to be, place it inside of the graph, and then put it into the structure of the graph at the same time. And that is truly what allows Quine to run at 1 million events per second, which is what we just accomplished, as well as keep up with event streams that are coming from any number of data sources, multiple Kafka topics. It can be coming from files, mixing all of that information together and taking insights all at the same time. And everything's indexed very deterministically. We can take the information from any event and tell you what the node ID would be from that.
All right.
So for us in this workshop, and we're going to pull this apart a little bit more whenever we go into the interactive component, we're going to take an event, and we have a string of events, and those events are JSON objects. And out of that event, we're going to create several nodes. We're going to use that ID from concept to separate this event into all of its component parts. So we're going to have an ASN, we're going to have an asset, a user, a client, and we're going to have an attempt, a login attempt. And all of that is going to be built. That graph structure is going to be built in real time as the events are streaming in from the event data or the components inside of the JSON object that is the event. And we'll materialize all of these nodes inside of the graph and create the relationships in them so that we can basically create an event graph that we can watch for a specific type of events. And if you go forward, I think the events next.
There we go.
So as I said, we're looking for kind of like an advanced, persistent, like slow type of an attack. So what we're looking for is a single user, in this case, a contractor, that has made a series of failed attempts to log in. And we chose 4. 5 typically will lock an account, but 4 won't lock an account, and 3, if you do them quickly, will trigger typically the "oh, you've forgotten your password" type of activity. So we're going to look for 4 failed attempts in a row without a successful attempt in between them, and then we're inside of Cypher. So 4 failures and 1 or more. We'll show you that there's more after this. 1 successful attempt. We're going to trigger that for analysis. So basically, we're going to raise that to an alert dashboard, or we're going to send it to the security ops team and say, we believe there's something suspicious going on with this account. And we're going to play the role of the analyst today. We're going to get that, and we're going to go take a look at what's going on with the account.
I think the cool thing too is that when you look at this slide, you can see that those attempts are a couple of days apart, and in some cases several days apart. But still, it's those attempts that kind of generate that pattern that we can look for. So yeah, I wanted to point that out because I think that's pretty cool that it finds it slowly over time. All right.
So just kind of foreshadowing what we're going to take a look at inside of our recipe. The middle of the screen there where it says query and starts with the word match, that is what the Cypher looks like for matching the event that we just had up and that we had modeled on our screen. So we're going to match it, and then we're going to take action on it. So the first match that's under the subquery for 4 consecutive fails is going to be what is running inside of the nodes, the actor component of the nodes. They're going to be looking for matching that complete set of events, that complete pattern. And once it does, the node that matches is going to trigger this alert that is going to create an output that'll show basically a URL on our console. We'll command click on that URL, and we will go into the graph and we will take a look at what's going on inside of that event.
All right, Michael, we have a question inside the chat. Is pattern matching done over the graph in memory? And then a two-parter, can it also be done over persisted data in Cassandra or ASTRA DB?
So any node that is associated with a pattern match is going to have an actor behind it, and 1 or more actor models behind it. And depending on how old the node becomes, and basically the tuning of how many nodes will allow to stay in memory, that node may be persisted and may be out of memory, or it may be in memory. But the node that is paying attention to the last piece of the match, so we deal with these things called half edges. So the node that is keeping track of the overall pattern match will always be in memory. But the nodes that are part of the match may either be in memory or they may actually be living inside of the persistent data store at that point in time.
Okay. Well, thank you. And I suppose we should point out too that, that a lot of times with Cassandra, we'll talk about nodes and we'll be referring to like a physical or logical like compute instance. But in graph, that means something different.
Right. In graph, you can think of a node almost like a row in a tabular data, in a tabular data form. So the node is going to have properties, which is usually what are the fields inside of a tabular type of data. Or you can think of a node as an object in like a document store or something like that. Either one of those mental models works for what a node is inside of our graph.
Gotcha. All right. Well, I guess we can move along to the hands-on portion here. So for those of you following along at home, you can jump to the README. We're going to go through steps 4 and 5 for this one particularly. So let me escape out of here. And all right.
Can you maximize your browser, please?
Yeah, I will. I will. Let me.
And today might be one of those rare days where we may get done earlier, right?
Yeah, so far so good, right? I know we're so used to running over. All right. So for those of you who haven't done it, you can go ahead and click this button here of Create ASTRA DB. And I'll go ahead and open this up in another tab. So essentially, we want to create a new database called Workshops, and we want it to have a key space named Quine. And just, for reference, the ones that come up that you don't need to put payment info for are in GCP, and specifically, it's the US East one in Monk's Corner. And I think that's South Carolina, if I'm not mistaken. All right. So if I get to here and I say create, actually I can zoom in on this a little bit to make it easier for those of you watching at home. And click into create database. So I'll call this Workshops plural. That's important. And for my key space name, I will spell Quine correctly. Then I can scroll down a little bit here. Make sure we're on Google Cloud. I am in North America. And Monk's Corner, South Carolina. There we are. And I can say create database. All right, so this will spin for a little bit. And then it should drop me back to the dashboard. Oh, right. I get my token details. So important. You can either download or you can actually hit the copy button here. I'm going to do that. Just to make sure that all gets pasted somewhere off screen. All right. So let's go to database here. Now, for those of you who have been through a workshop or two with us before, and maybe you already have Workshops database, you can go ahead and click on that database. And if you haven't had it in a while, it might have been, or haven't used it in a while, it might have been hibernated. You have this, there's this resume database button. You can go ahead and click. And again, give or take, 2 or 3 minutes, it'll work its way back. All right. So we've done that. Yep. And we've shown how to get the token. Okay, so the next part is really about setting up Quine. And of course, for those of you who have been with us on some of these before, we're going to open this up in GitPod. So I'm going to right click here and open that in a new tab. And GitPod is going to start spinning its way up.
Yeah, Aaron, one thing I'm noticing is, maybe I'm noticing it late, is you're a little bit dark there. Any chance you can add a light or something?
Oh, yeah. Well, here, GitPod's up now, and I use non-dark mode for GitPod. That's like the only thing that I don't use in dark mode, to be honest. But yep. No, that's a good point, Rags. All right. So Gitpod should come up. It's like this. You don't need a whole lot of the the extra windows open up top. Sometimes it's helpful to keep the README up there just to be able to get a quick reference to the instructions. One thing we're going to have you do today that's a little bit different is all of you at home can help us try out a new tool that our own Cedric Lunvin has kind of driven a lot, is this ASTRA shell. So this is a cool way that we can interact with our ASTRA instance without having to leave Gitpod. So I did some automation foo behind the scenes to try and make this as seamless as possible. But if you can, make sure you have your token ready that you just copied. I'll zoom in just a little bit here. But you'll notice this last message you get here is open a new terminal and run ASTRA setup. Oh, and you can close this terminal window. So let's go ahead and hit the plus here, and that'll open up a new bash terminal window. And I'm just going to say ASTRA setup. All right, so you'll notice what it asks down here is to enter your token.
And as strange as it may seem,
right.
Copying the zip file was such a pain.
All right, so I'm gonna go grab my token. I'm going to paste it in. Now you notice that it's asking me if I want to allow pasting into this this window, and I'll say yes, I do. All right. Okay, so now it's saved the configuration. The cool thing is that you can actually interact with ASTRA via the ASTRA shell. So I'll do an ASTRA DB list. All right, and you'll notice that I have a few databases back here. I have one hibernated, one active, and one's initializing. So let's have a look back at oh, sorry, I'm going dark again.
Sorry.
Back at our Git repo, and we'll take a look through. Okay, so if we've done everything right so far, this start.shell will actually bring up Quine and connect it to AstraDB. Now, I'm going to run this, and I know it's going to fail, and that's going to be on purpose. So let me go ahead and just start that. So this will start to come up here. Oh, and it didn't like... Okay, so what happened here is that the download of the secure bundle failed, and that's going to be taken care of automatically, assuming it can find your database. Now, my token, however, does not point to my workshop's database. So if you are using a database in Astra that is not named workshops, you want to go and modify it inside of this .env file here. That is where you can go ahead and make that change. So again, if you need the name of your database, you can do a quick Astra DB list. And I'm going to connect to my Stacko GCP one. There we go. Okay, and as long as I'm here, I'm also going to, because I know that I've run Quine before, and there are some nuances that happen if you've already run it, as far as getting it to pick up the ingest appropriately. I'm going to run this truncate table shell just to kind of clear out. Oh, it didn't like that at all. Well, folks, remember from last week, this is, we do this live. Let me have a look at this quick. Oh, and yeah, don't save.
It might again be related to workshops. Maybe you need the right.
There we go. Let me just force that in there for now. And then we'll say truncate. There we go. Now it should connect. Okay, there we go. So that shell completes. Now let's go ahead and rerun our start.shell. Okay, so now that we have the ASTRA secure bundle and everything, we have our tables cleared out. We should have a brand new Quine table structure underneath. Okay, and okay. If you get to this point where it says the Quine web server is available, and you notice your standing 1 count starting to tick up, you're in good shape.
Should we wait for some couple of thumbs up?
That's a great idea. Yeah, yeah. You know, I will mention that while this is running, one thing that that Michael Rags and I have run into a little bit, there's this section I have in here on troubleshooting. All right, it's this section right here. It'll describe a lot of the common errors that we've seen during this process. One in particular relates to this snapshots table. So if you see this error around, you know, like clustering key columns not matching exactly, there might be a table you'll need to add back in with its CQL. So we'll let this go for a little bit. Okay, I see one setting up still. Yep. Oh, somebody's really excited in the chat about the ASTRA shell, ASTRA CLI. Cedric, I'm sure he'll be happy. He was really stoked, you know, to get this project out the door. If anyone has any questions or has any issues, you know, again, feel free, put them in the chat here. Or actually, you know, I should really have Discord running, although I'm sure like Artem and some of the other folks are keeping an eye on it for us. So now, Michael, if I remember right, this standing 1 count is going to increase, kind of simulating those password or authentication attempts coming in. And then sometime around like the 20,000 mark, that's when it's going to find the anomaly, right? Oh, Michael, you're muted.
Yep. Yes. We're sorry. I was typing. I have a loud keyboard. So, so we're using a set of data that the event completes at around 24,000 type of events, and then what we'll see is that standing query create the emission of the event, if you will. So what we can do while we're waiting for that. I can walk through kind of what the recipe is, if you will.
So, Michael,
so a recipe
do I need
Quine,
to share your screen?
Yeah, it would probably be best to share my
second.
screen. Yeah, no problem. So a recipe in Quine is everything that's needed to basically do a particular set of analysis. So we have all of the configuration for this event set up in something called a recipe. And basically a recipe contains all of the API calls, if you will, to be able to configure Quine, as well as it also has API calls that allow us to change the way information is displayed inside of the exploration UI. So that's really what is inside of a recipe. And it's just a flat YAML file, and we can walk through that. So Rags, whenever you're ready for me, I can share my screen.
Okay. Is that the one that you have?
Oh, there we go.
Okay, perfect.
Okay. So I did run into that issue. Where the snapshot table wasn't created, so I ended up having to go and inside of my. So anybody that had to do that, the instructions are here, and basically you can restart it. And basically, so what you can see is I started Quine is running, an ingestion of just over 14,000 events. The standing query has done 14,000 things. That is, and then there's this other thing called a standing query. So inside, and I also wanted to point out in dashboard for my workshops database. This has been running for a little while. You may want to change this in like 10 seconds if you're not seeing anything yet. But you can see the load that I'm putting into ASTRA DB right now. We're persisting all of our nodes that are not interesting to this query into the persistor, which is pushing out into ASTRA DB. So what's making this happen?
Hang on a sec. It sounds like we're getting an echo from Michael. That's what folks are saying in the chat. Regs, can you confirm that?
Regs, are you hearing an echo?
Oh, they said it stopped now.
Did the echo come back when I started talking?
Oh, and now they're saying it's still there.
Yeah, now I can hear it again. Yeah, now I can. Sounds like there's a little echo there. I don't know why. Sure. So what I did was I opened up the password spraying YAML file, which is our recipe. Hopefully there's no echo now. So the recipe has a description in it, and you can go and pull down a version of this recipe from the Quine.io website in our recipes section. So here's this ingest stream, which I talked about, the architecture. We're ingesting a file, and we're matching a bunch of nodes off of the file. So this is where we're building that structure that we talked about inside of the graph. And actually right here, just to point it out, I've run through my 24,000, and there's actually 75,000 events inside of this data set. And here's the output of what I'm going to get to, which is standing 2. And this is the actual detection of a password spraying attack. And we'll talk about how to deal with that in a second. So the Cypher query that is the ingest query is doing several things for us. It's reading from the JSON file, so Cypher, and then processing that file with Cypher, and it's creating the graph structure with all of these basically new nodes and parameters that we're taking from the original event and populating into the nodes. So it creates a client node, a user node, an attempt node, and then an ASN and an asset node. And it populates all of those with the pertinent information from the original event. And then it creates the relationships, if you will, between all of those nodes. So basically one event ends up like a little subgraph inside of the graph. And that is kind of like our extract, translate, and load components. So we've translated that or transformed that data, and we've loaded it into a graph. Now inside of the graph, we have these 2 actor-based standing queries. The first one's going to look for a specific pattern that is an attempt originated by a user originated with another attempt. And basically what it's going to do is it's going to find and connect all of the attempted logins inside of the graph using a couple pieces of Cypher, and then have a sequence number that's put inside of there. So that is what this standing 1 count is. So every single time a subgraph is created with our ingest, standing 1 connects that to the rest of the graph. So we have a continuous or a contiguously connected set of graph data. And then our second pattern is going to look for what I showed on the screen earlier. It's going to match those 4 consecutive failed attempts, and then it's going to write to standard output all of the information associated with that event. And that looks like this whenever it occurs inside of your console. So what's nice about this is because we've built a fully connected graph, this has all of the information for me to hold down. I'm on a Mac. I can hold down my command key and I can click on this. One interesting behavior that I'm getting inside of the terminal for VS Code, I'm using VS Code on a Mac, is you see how this is pulling the last double quotes. We don't need that last double quotes. So you can command and click on this. It'll open up, but it's going to get mad. It's going to tell you it's not a well-formed cipher query. So if we go to the end of it, we take off the double quote and we hit enter. It's going to go and it's going to query the graph. And it's a little slow. There we go. It's going to query the graph. And this is our event right here. So here's our successful event. Here's the previous event. It's easier for me to form it going backwards. Here's the event before that. Here's the event before that. And here's the event before that. So this we can take and we can right click on this node and we can get all the local properties and we can see all of the information that was populated into this user node. And we can see that Tanya Schaffel, who was a contractor, we also kind of know that the last time that we actually saw her successfully log in was on 5/11/22, which is, kind of before. Oh, that's before these. Oh, actually, that's because those credentials were used. So we can see everything about who this is. We may know that Tanya was, her contract ended maybe before some of these events, and she shouldn't be logging in at all. So this could be an interesting analysis to go and say, why is this account even still being used? Did we forget to deactivate it or something like that? Another interesting thing that we can continue doing is we can follow more of this structure. We can right click on a node, and these are all queries that we've written inside of that recipe so that we can explore and we can analyze what's going on inside of the graph, using the information and using the data that's here. We can look at the next attempt. And one great thing about graphs is they like to reformat themselves every time. And we can follow this, and you can see there's a bunch of attempts that are going to happen here. But we also have a query, since this is curated data, we can come up with the entire stream of events that have happened for this user. And this little swirly thing says that the graph is still querying, and I can show you that we're still ingesting inside of here. So we still haven't hit the end of the data stream. But I can do basically a full audit on any user, and we can see that Tanya was logging in primarily, and every now and then she'd mistype her password or something like that. But she was primarily coming in through a VPN, right? And we all of a sudden start seeing, here's our pattern: failure, 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 success, and then a stream of successes. So this account's been being used quite a bit after it's been compromised. And these are all coming from off-net. So this is definitely something that the security team would want to take a look at inside of a threat analysis or a threat behavior type of thing. And this alert happened as soon as we saw this event right here. And you can see, like Aaron pointed out, these were weeks, sometimes even multiple weeks apart inside of our logs. But as soon as that event happened, this success, the security analyst gets an alert on their console and they can go taking a look at it. This didn't have to wait for a batch run that may only happen once a week. It didn't have to wait for a bunch of events that, there might be some false positives in there, but this is a real live password spraying attack that can be dealt with immediately. And this could have gone on, and we can already see that this has gone on and multiple times after the original event.
Michael, we have a question actually from the chat on how do we get the link again? Do you think you could just kind of show where you found that?
So the link, this is the terminal that I started running Quine in. So here's where I launched the start script. So wherever you launch the start script for Quine, And when you see Quine running, once you get to about 24, almost 25,000 events that have been ingested, you will get this link that shows up basically right above the counters for the standing queries. And it's an event that is alert and a match event. And if you hover your cursor over the URL component of that, it'll highlight, and you can hold down Command key, which turns my cursor into a pointer, and you can click on that. And again, it's pulling inside of VS Code for some reason. For me, it's pulling this extra double quote.
It did that for me too. Yep. So I had to pull that off.
So that's the exploration. And again, we can take a look at the database, and here's the activity that this recipe, ingesting all of this files, is putting work onto AstraDB. And you can see, basically I'm done pretty much ingesting, it looks like, or pretty close to being done ingesting. Most of the nodes, once the event is found, most of the nodes, because we're looking for a pattern, are no longer part of that pattern. So the actors have put a lot of the nodes to sleep and pushed them off into the database. And there's not as much recalling and looking for different parts of a pattern match, if you will. And you should see something similar. And this is in my workshops database in the health tab for the console. So if you go from our review to health.
All right.
So Aaron, I can pass it back to you.
Sounds great. I suppose that.
And maybe we can also get some indication of, are people seeing the event? Have people completed ingesting all of the events yet? Unfortunately, because I'm using one screen, I don't have the YouTube up at the same time.
Okay. Yeah, just getting some questions around, like an exception that someone ran across. So we're trying to see if, maybe they have the, the extra double quote on there, or if there's something else that, that could be going on. As you can see, mine is still ticking along here, I think. But yeah, I actually here I can demo that part too, where if I hover over here, and hold down Command and I hit that, it'll open up a new tab, and of course it'll totally blow up. But up here in the query window, kind of like Michael was demonstrating, I can get rid of that tailing quote, and then if I hit query, this should all fall right into place.
Yep. And it's spinning, so it's searching.
There we go. All right, so we have that user, and then kind of like you were doing, I can arrange that, with events in order as to how it makes the most sense here. But yeah, and again, you see those different attempts that have resulted in that actual good attempt. And what is that? Is that April 14th? It looks like. Yeah.
Yep.
All right.
And Aaron, I forgot to show, but if you can click on the thing that looks like a speedometer on the left nav.
Oh, left nav, right?
No,
yeah,
on the left
right,
nav.
That does look like a speedometer. I got you.
Yeah, there you go. So if you click on it, so this is what the Quine system dashboard looks like. So this is where you can see the amount of work that's being done from the Quine dashboard point of view. And you can see how many nodes there are, how many of them are awake in memory, how many shards the system's running, some information about some meta information about the types of nodes that are inside of the graph, how many properties they have, how many edges distributed across the graph there are, as well as you can see some of the persistor stats, for basically the performance stats,
Right,
latency
right.
as well as calls and stuff like that. So we have instrumentation
So now
inside of here as
the
well.
node edge counts over here are separated into two different like bar graphs. So is the smaller one more related to like the match that we noticed, the anomaly?
So if you the way that we do the node edge counts is we basically are looking for something called supernodes generally inside of there. So any bars that are farther to the right, they have more edges than bars to the left, and an edge
Right.
is a relationship between two nodes. So it's that relationship. So what we're looking for is a good distribution of nodes with edges, and where we get concerned, like that bar to the right, there's somewhere between 128 and 2,000 edges, right? Where we get up to say 100,000 edges, then there might be something we want to look at optimizing inside of our query. We would call those types of nodes that are related to a very large amount of other nodes in a graph a supernode, and that can cause performance problems when we're including that node in say some type of an edge walk
Gotcha.
or a shortest path type of algorithm.
Okay, so we have a question from the chat. Also in the chat, Artem from our team said, "Great demo." So he thinks this is pretty good, So and coming from Artem, he is his PhD in computer science, so he's a pretty bright guy. So if you've impressed him, I think that's you can count that as a win right
awesome.
there. But also, somebody said, that they're running into that clustering key exactly match columns error. Now that's the one that you can fix by recreating or by rerunning the create of that snapshots table. Is that right?
Yes, rerunning the create of that snapshots table. Yeah. And that is in the, so if you go back to your window, your
and it's under
yeah,
this section
so it's right
that
there.
I have linked called troubleshooting right here. You'll notice that if you scroll down, you'll find that clustering key columns match exactly error, and then using ASTRA shell, you can just use that to connect, and you can rerun that that table DDL, which should fix that.
Yep.
All right. Well, I suppose we can pop back over to our slides. Oh, sure, we could do that.
So another thing that if you go back to the Quine dashboard,
I just killed it.
Oh, did you close the window?
Here, I can. Oh, come on, come back. I wonder if I have to do a stop to make sure it stops clean. I killed it. Yeah, I know.
Oh, you killed it. Oh no, it should. Well, now that you stopped it, it's gonna be done. I can share real quick. Let me just share. So inside of Quine, this left nav, so not only do we have the system dashboard, which is going to show you what's going on, we have the data exploration window, which right now has a query running in it. So you can do different types of queries, like get different nodes and stuff like that. But this one that looks like documentation, we have live API documentation inside of here. So you can go and take a look at the ingest streams. So you want to look at, list all the running ingest streams. You can actually, let me make my window a little bit bigger. You can launch these API calls directly from the documentation. So here's our ingest stream. It's running. Here's the query. It's all been serialized into one line, but it can show you, basically throughputs and stuff like that. And this can get really powerful if you want to say inject new Cypher queries in. You can at any point in time craft a Cypher query inside of the documentation, basically send it in and get all the information back out. And that's a really powerful piece. This is also where if you're creating a recipe and you want to create, like, say, a new ingest stream, you can look at the documentation on quine.io, docs.quine.io, and inside of here there's a REST API reference, which is the exact same representation as the live documentation inside of Quine. But if you want to create your own recipe and you're going to do that, you can start, and all of the recipe components, we go through and we describe what the API version of it is inside, and the API version comes directly from our API documentation, and then the YAML version, or the converted YAML version, and you use YAML inside of your recipes, and that's kind of a foreshadowing of how you're gonna do some of the homework components. This is where you're gonna find the format for if you want to create your own recipe, or if you want to modify recipes and you want to understand all the parameters that you have available to you.
Oh, excellent.
So I can pass that back to you, Aaron.
Right. Let me... Oh, not that one. There we go. Okay. So, we've gotten through the hands-on. Let's take a look at what's next. Well, oh, look at that. Menti is next. I was thinking that maybe we had a touch point in there about the homework, but I guess we can get to that once we get through Menti. How's that sound, Rags? All right. Rags, you want to share and fire at Menti? Hey, I hear you. Let me ask in chat. And for those of you who still have that on your phone or in another tab, you should just be able to pop right back over there and be able to join. Oh, Alan says that we can't hear Rags. Yeah,
Okay.
hearing some no's.
Can you guys hear me now?
That's all right. I can talk
think you
through
should
it
be able to
otherwise
hear me
too.
now.
Yep. Speak up if you can hear Rags. Oh, Artem
Right.
says yes.
No
I think we're
echoes, I'm
good.
good. All right, let me start the music. Let's get some music going, and we should be ready. 3161
And what's the code again?
For those of you, if the music is too loud, let me know, please.
Yep. So far, so good. All right, so going right to the first question.
Answer fast, but most importantly, answer correctly.
What is a benefit of using Cassandra with Quine? See how everyone comes through on this one.
There's also a test for the speakers. Did we set up the questions properly?
Oh, hey. Well, we had 9 people get it right. That's good. Yeah. Better performance and scalability. Unfortunately, it's not easier indexing, and it's definitely not faster joins. All right. So how did everyone fare on that one?
Sash fastest.
Yep, Sash in the lead. All right, next question. What is ASTRA DB?
Give me.
I always love the answer. It's an album by Radiohead. All right, Cassandra as a service in the cloud. All right, everybody got that one. Excellent, that's good to see.
Right?
That was an easy one, yeah. That's a softball that we threw everyone.
Sash still the fastest.
Yep. Sash coming up, but it's still early. It's still anyone's game. All right, next. What does an ingest stream do in Quine? All right, let's see how this one came out. Oh, hey, everyone got that one too. All right, connects a data source to Quine. Outstanding. Good. All right, see how our leaderboard looks.
Looks like somebody else is fastest. DS.
The top three does not change. All right, question 4. Which is a valid ingest stream source for Quine? Oh, this is the good one.
Did we talk about this?
I think we covered some of it. Yeah, all are valid. You know, I suppose we could have covered that one a little bit better, you know, because we really were using the CSV file for the exercise. We did specifically mention Kafka, but it does also work with Pulsar or even a WebSocket connection. So, yeah.
I think Sash is not going to be happy.
All right. Well, we had some shakeup on that one. All right, number 5. How is data indexed in Quine? And this I know we covered. All right, let's see how we did.
Ooh, across the board.
Most people got it. That's good. That's good. Yep. Deterministically calculated node ID using that ID from method. All All right, let's see how the leaderboard shapes up.
Lots of changes.
Oh yeah, looks like DS is still going strong. Yeah, but a definite shakeup, that's for sure. Going into the last one. All right, what is the standing query?
Is there a sitting query?
Yeah, this is a tough one. Curious to see how this one pans out. Yeah, this was the deal breaker. Query that matches a graph structure incrementally.
So congratulations, Mars. For those of you who are in the top
Mars.
three, that's Mars, DS, and Homer. Do not take a screenshot of what you see on YouTube, but take a screenshot from your phone, and we'll tell you momentarily how to send it.
Yep. Actually, Regs, I have that slide up if you want to flip. Oh, I suppose I can. Yeah. Oh, I'm sharing. Yeah, you can flip back to me, and they should see that. Oh, and then a follow-up to the quiz.
It should be at just the, not just he, but that was my typo.
Oh, yeah.
That's great. Everybody thinks this is the right level. So it wasn't way too easy. It wasn't way too difficult. Perfect. That's kind of how we like to see. And
yeah.
Quick survey to help us. What do you like most? What do you think we should improve? I'll leave it there for a few minutes. Just a little bit. And if you like it, just put it in.
Oh, and Alan really wants to know what the
Music
soundtrack is for the
okay.
quiz.
All right. We'd like to see something more than the music. I think.
Hey, someone said the music is good. All right.
I think Michael was great, right? And Zon was great.
Yep. Yep.
Thank you.
More streaming examples.
More streaming examples. Yeah, I know. I've been thinking that for a while too.
Kind of do it real time kind of thing, right? Yeah. All right. Let's try to wrap this up. Give me a second before. All right, I think you are on, Aaron. Let's take us home.
Oh, excellent.
What? I don't understand.
And again,
that
just
more
to
workshop at lawn.
what? Oh, was
Yeah,
was
it
that
was
from
on Menti.
Menti or
It came
something? Or oh, okay. Okay. Anyway, just to Reg's point from before, make sure you're taking the, for those of you who won in the quiz, make sure you take that picture from your phone or on your browser, so it says like you finished third or you're the winner. Yeah, that'll be good, and you can fill it out at dtsx.io workshop-swag, and you can submit that. So easy. All right. So hey, homework. For those of you who are so inclined, and you really want to get that badge, you can go ahead. And Michael and I went back and forth on this a little bit. We kind of thought, oh, hey, it'd be great to have a new recipe, but we don't want you to spend because you can spend like a good week or two building up a new recipe and getting it right. So take an existing recipe and modify it to do something new. In terms of like finding those, and Michael, I'm going to need some of your guidance here a little bit, but I'm on Quine's website. They have a
So that's, yeah, go to Quine website. That's the
that
dot website.
Right. So
Yeah,
Quine.io. All right.
Yeah. So Quine is an open source project that is, maintained and curated by the company That Dot, which is where I work. There is an enterprise version of Quine. Quine is the product, and the open source core runs as a singleton. And if you want to go and learn more about how to run clustering or how to do some of the more advanced things, we have a shallow learning AI called Novelty Detector. You can go to the That Dot website and learn about those there. But for everything that we've done this time, it's in Quine. So if you go to the recipes page there, absolutely.
Page, that's what I was looking for. Yep. And there's the password sparing one that we just did. Yep.
Exactly. The Apache log analysis one is very interesting. The Ethereum tag propagation one is an interesting one. There's a Wikipedia recipe that I'm not seeing right now on that list, but there is a, there it is. The Wikipedia recipe, which takes from the Wikipedia stream. That is only taking page updates right now. There's multiple streams that are in the Wikipedia servers that you could join information together and get interesting insights. The Wikipedia recipe is also what we use as part of our Getting Started guide. So
I love this pie recipe. That one sounds awesome. Just for me.
Yep. So for Pi Day this year, one of senior developers put together a recipe to calculate pi, and it streams pi's values for quite a while, actually.
That's awesome. All right, I'm gonna have to check that one out for sure. All right. Okay. Otherwise, just to finish some things up here, we have some Cassandra days that we're hosting. For those of you, who want to learn a little bit more about Cassandra, and listen to some great talks from some folks in the area. We are running 3 simultaneous Cassandra days on November 10th. And there's going to be one in Santa Clara at, I think it's Intel's headquarters, and then one in Seattle and Houston. And those are both on the Microsoft campuses in those cities, respectively. And actually, Michael, I think you're speaking at one of these, aren't you?
Yes, our CEO, Ryan Wright's going to be speaking in the Seattle Cassandra Days, and I'm going to be speaking at the Houston Cassandra Days. So if you'd like to meet in person, I'll be in the Houston Cassandra Days.
Excellent. And then, of course, we also have, KubeCon.
Yeah,
right. Yeah, Rags, why don't you take this one?
Yeah, so this is KubeCon, Cloud Native Con, which is happening next week in Detroit. So you're welcome to, if you're there, just stop by our booth and say hi to me. But also one more thing about Cassandra Day that you probably forgot, Aaron, was that you can see the movie Wakanda Forever, right? So, and you can see it one day before the rest of the world has an opportunity to see it.
Yep, that's a good call out. This, going to Cassandra Day gets you into a preview of Wakanda Forever the day before. So that's a huge deal right there. All right, and then of course we have our Cassandra Summit coming up in March. We used to do these back in the days. Back in the days, like 6 or 7 years ago. So I'm so excited we're getting back to do these again. So yeah, we're talking about training days, and then having talks from folks all around the world. And actually our CFP is out there. So if you check out our site and you want to submit a Cassandra talk, you definitely can by going there.
Yep. And Ryan let me know that he will be speaking at the KubeCon conference as well. So if you want to meet him, yeah, he'll be in Detroit as well. And you can look for him.
I
Just
tried
probably
to
out,
find myself.
either go to his speaking session or find him out.
Yeah, yeah. Well, excellent. Okay, and of course, you know, we have this promotion going right now, that if your company books a meeting with us, you can be entered in an entry to win a Tesla. So yeah, highly recommend that. You know, in fact, I wish I could do that. All right. Well, hey, folks, thanks everyone who stuck with us through to the end. And thank you, Michael, for coming on as kind of a guest host here. Just yeah, this is such a cool tech. You know, I really feel that like graph tech is one of those things that's kind of ahead of its time. It's like the rest of the industry hasn't caught up to it yet, and it's so awesome to see implementations of it like this, and just some of the cool things you can do with it that, you know, other databases or other streaming ingests, you'd have to do a lot of work in order to get those same results for sure.
Yes. Yeah, we're really proud of it, and we're really excited about the future of streaming in all of the data sciences. So like data scientists, data engineers, data modelers, all of those specific disciplines can take a advantage of streaming data that they couldn't do using, you know, tabular or document-based databases.
For sure.
Yeah.
All right. I think that's all we've got. Hey, thanks everyone. Have a great day, and we'll see you all next week.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.